Hello everyone and welcome back to Tesla Harmonics. Today I want to take a look at Module 26306-23, Distribution Equipment in the NCCER 11th edition. This will be Section 1.00, Electrical Distribution System Components. Electrical Distribution System Components. Utility companies take high voltage power from the power grid and reduce it to levels suitable for distribution through substations. From the point of service, consumers must control, distribute, and manage the power supplies of their electrical needs. Switchgear is classified first by type of construction and then by the voltage rating. Any voltage up to 1,000 volts is considered low voltage by the NEC. Medium voltage refers to systems rated between 1,000 volts and 35,000 volts. Metal enclosed switchgear is applied at medium voltages. The term switchboard may be defined as a large single panel frame or assembly of panels on which switches, protective devices, buses, and instruments can be mounted. Switchboards are used in modern distribution systems to subdivide large blocks of electrical power. Switchboards are often located where the main power enters the building. When switchboards are located downstream from the service entrance equipment, they are referred to as distribution system equipment. Typical switchboard components include the following: circuit breakers, fuses, bus bars, motor starters, ground fault systems, instrument transformers, control power transformers, and switchboard metering. Circuit breaker classifications: air circuit breakers, oil circuit breakers, vacuum circuit breakers, and gas circuit breakers. Circuit breaker rating information includes voltage rating, current rating, and interrupting rating. Low voltage spacing requirements. All switchboards have spacing requirements. Spacing requirements are measured between live parts of opposite polarity or between live parts and grounded metal parts. Wire terminations must be prevented from rotating. Cable bracing. All construction using conductors and having a short circuit rating greater than 50,000 RMS symmetrical amperes requires a cable brace. The cable brace is intended to be mounted in the same area allotted for wire bending. The cable brace requirement does not apply to load side cables, main breakers, or switches. Switchgears perform two basic functions. They provide a means of switching or disconnecting power system apparatus, and they provide power system protection by automatically isolating faulty components. Switchgear classifications include metal enclosed switchgear for low voltage, metal clad switchgear for low and medium voltage, and metal enclosed interrupters and unit substations. Switchgears consist of one or more freestanding units that are mechanically and electrically joined. Metal clad switchgear enclosures are divided into three sections. Switchgear enclosures provide support and mounts for installing electrical components. Switchgear is manufactured and tested for more exacting standards than switchboards. Wiring system. The NEC requires wiring to be supported mechanically. No incoming wiring connections may be made directly to door-mounted devices. Wires from doors must be neatly cabled so that the door can be opened easily without straining the wire terminations. All control or metering wiring entering or leaving the switchboard should terminate at terminal blocks. Ground connections on a potential transformer or current transformer secondary terminal must be connected to the ground bus. Switchgear handling, storage, and installation. Upon receipt, inspect switchgear for damage. Follow manufacturer's guidelines for rigging switchgear. Store switchgear in a clean, dry location. The main bus that is usually removed during shipping should be reconnected. Verify phasing of each cable and make sure all equipment is correctly grounded and bonded. Medium voltage limiting and high voltage limiting switches. An MVL switch is a switching device for circuits up to full interrupting current of the switch. Limiting switches are single throw devices. HVL and MVL switches can provide both switching and overcurrent protection. Ratings. Ratings for limiting switches include the switch kV, the basic impulse level, the frequency, the withstand kV, capacitor switching, the fault closed current, short time current, continuous current, and interrupting current. Some variations. There are a variety of switches with different characteristics including upright, inverted, fused and unfused, duplex, selector, or motor operated. Opening operation. In the closed position, the main switch blade is engaged on the stationary interrupting contacts. As the switch operating handle is moved towards the open position, the stored energy springs are charged. The action of the switch operating mechanism forces the movable main blade off the stationary main contacts while the interrupting contacts are held closed. Once the main contacts have separated well beyond the striking distance, the interrupting blade is suddenly forced free and flips open. Closing. When the switch operating handle is moved towards the closed position, the stored energy springs are being charged and the main blade begins to move. When the main and movable blade approaches the main stationary contacts, a high voltage arc leaps across the diminishing arc gap to complete the circuit before the contacts meet. The spring pressure and the momentum of the fast-moving blades completely closes the contacts. The interrupter blade is driven through the twin stationary interrupting contacts, latching in place. Warning: maintenance and testing may only be performed by qualified personnel under the appropriate safe work plan or permit. No work inside of breakers and switches beyond termination to the conductor should ever be performed by the electrical contractor or electrician without specific oversight and direction from the equipment manufacturer. Ideally, the equipment manufacturer should be hired to perform the work, which may include normal maintenance of the equipment. Maintenance: HVL and MVL switches must undergo routine maintenance. A sluggish switch is one that hesitates on the opening cycle. Observing the interrupting blade during the operation is the proper way to determine sluggish operation. Sluggish operation must be resolved to prevent the switch from locking up completely. Voltage pressure switches are inexpensive and can handle a higher available fault current than circuit breakers. Voltage pressure switches can be manually operated, shunt trip operated, or motor operated. Voltage pressure switches rely on an external signal to operate. Ground fault. Ground faults exist when an unintended current path is established between an ungrounded conductor and ground. When a ground fault occurs, current increases, eventually reaching the ground fault relay pickup point and causing the voltage pressure switch to trip. If a phase relay is installed, it will trip a voltage pressure switch when a phase is lost. If one of the inline main fuses were to blow, the blown main fuse detector would detect it and trip the voltage pressure switch. Maintenance: voltage pressure switches often fail due to the lack of proper maintenance. Annual maintenance is crucial to the reliability and safety of voltage pressure switches. When the possibility of a conductor becoming inadvertently re-energized exists, temporary grounds must be applied. Protective grounds consist of cable connected to de-energized lines and equipment to limit the voltage difference between accessible points at a work site. Transformers. Transformers are used to step voltage up and down in the power transmission and distribution system. As current flows through a conductor, a magnetic field is produced around the conductor. If the conductor is wound into a coil, the magnetic field expanding from each turn of the coil cuts across other turns of the coils. The operation of a transformer is based on the principle that electrical energy can be transformed efficiently by mutual induction from one winding to another. Transformer nameplate data. Common transformer nameplate data includes the BIL, the phase, the frequency, the class, the temperature rise, the capacity, the impedance, and the phasor diagrams. Dry transformers. Large transformers are typically oil-filled for better cooling and insulating. Dry transformers are used in applications where oil-filled transformers would pose a fire hazard. Ventilating louvers are provided for air circulation. Sealed transformers may be used for water submersible applications, and nitrogen is used for insulation and cooling inside sealed transformers. Instrument transformers are used to protect personnel and equipment from the high voltages and/or currents used in the electrical power transmission and distribution, provide reasonable use of insulation levels and current carrying capacity in relay and metering systems and other control devices, and provide a means to combine voltage and/or current phasors to simplify relaying or metering. Instrument transformers. There are two types of instrument transformers: potential transformers and current transformers. PTs are designed to reduce primary system voltages down to usable levels for metering. The standard secondary voltage for a PT circuit is 120/115 volts. PTs can be dry, case epoxy insulated, oil-filled, or sulfur hexafluoride insulated, depending upon the primary circuit voltage level. PTs must have their secondary circuits grounded. A CT is used to supply current to an instrument connected to its secondary. A CT uses the circuit's conductors as its primary windings. CTs are manufactured in 4 basic styles: donut, bar, window, and bushing. CT selection depends on primary current rating, maximum burden, and saturation characteristics. Warning: the voltage level across a CT's secondary terminal can rise to a very dangerous level if the secondary circuit opens while the primary circuit is energized. If the secondary circuit is open, there will be no secondary ampere turns to balance the primary ampere turns. So the total primary current becomes excited current and magnetizes the core to a high flux density. This produces a high voltage across both the primary and secondary windings. The high voltage endangers the life of anyone coming into contact with the meter or leads. This is why current transformers can never be fused. A CT is the only transformer that may be short-circuited on the secondary while energized. Panel boards. Lighting and or panel boards provide circuit control and overcurrent protection for all circuits and power-consuming devices. Panel board construction. Main feed bus bars run the height of the panel board. The buses to the branch circuit protected devices are connected to the alternate main buses. The connections directly across from each other are on the same phase, and the adjacent connections on each side are on different phases. Identification of conductors. NEC Section 210.5C requires that where different voltages exist in a building, the ungrounded conductors for each system must be identified at each accessible location. Identification may be made by color coding, marking, tape, tagging, or other approved means. The means of identification must be permanently posted at each branch circuit panel board and must be readily available. For a wire delta connected system, the high leg or leg B must be orange in color, or it must be tagged using another effective mean to ensure it's readily recognized. NEC Section 110.15. Panel board protected devices. Circuit breaker selection is based on the following: proper overload protection, suitable voltage rating, sufficient interrupting current rating, short circuit protection, and coordination of breakers with other protective devices. A double pole breaker requires the same installation space as two single pole breakers. And some trade terms we should read over and become familiar with. And some review questions for this session. Which of the following is true about switchboards? Switchboards are always installed in cabinets. Switchboards only used at the service entrance. Switchboards are used to subdivide large blocks of power. Or switchboards are designed to prevent access to the panel. That's going to be C. Switchboards are used to subdivide large blocks of power. When installing wiring within switchgear, use self-adhesive cable ties every 12 inches, 16 inches, 24 inches, or 36 inches. That's going to be A, every 12 inches. The maximum voltage that a piece of equipment can withstand is known as its interrupting capacity, basic impulse level, current limit, or frequency. That's going to be B, basic impulse level. Voltage pressure switches are often used in place of circuit breakers, push button switches, main fuses, or MBL switches. That's going to be A, circuit breakers. A transformer's temperature rise rating refers to the normal operating temperature of the transformer, the maximum elevation above ambient temperature that the transformer can withstand without insulation damage, the difference between the temperature of the de-energized transformer and the ambient temperature under normal operating conditions, the difference between the temperature of the transformer when it starts and the temperature of the transformer while running under normal conditions. That's going to be B, the maximum elevation above ambient temperature that the transformer can withstand without insulation damage. A service panel has a 3-phase supply with 14 single-pole circuits and 4 3-pole circuits. The minimum number of poles required is 18, 22, 26, or 30. And they have D, 30. Alright, everyone, that was it for that section. Next section will be 2.00 installation requirements, and I will see you over there.